Okay, welcome back. So now we will continue our journey with the Bay mode. We were in the point of the brightness. We have discussed already the overall gain and the gain controlled sector by sector, also known as the GCC. Now comes a new point, and that is the dynamic range. The dynamic range might be quite novelty to you, or a forgotten function that many of you neglect to use or don't use or don't know. Whatever I introduce you now, I'm very happy to introduce you now to this novelty, and I'm quite sure it's going to be interesting. So let's take off. Okay, what is meant by dynamic range? Dynamic range refers to your range of grays. Okay, we're dealing with black and white, so the range of color here is gonna be grays. So here we have the black and the white and single shade of gray. So I would call this dynamic range of 3. Okay, this is my range. Now what happens if I increase this range? Okay, voila, I have a wider range of shades of gray, wider range of color, that is the gray. Now I have here my black, I have here my white, and 3 shades of gray instead of just 1. So I have here a wider range of gray. What happens if I increase it even more? As such, okay, here my dynamic range, I call it a range of, let's say, 20. So I have here my black, I have here my white with gray in the middle. Let's say around 9 shades here and 9 shades there. So I have wider range of shades of gray. So dynamic range refers to more shades of gray, wider shades of gray. Now, how can this be used? Okay, let's see how it can be applied on real ultrasound images. We have here the renal sinus, and we have here the renal parenchyma. Now in this picture, you can see the renal sinus as being almost white. The fatty sinus here appears as almost white, while the parenchyma appears almost black. The rest of the image is gray. I have here my dynamic range of 3. Now, as usual, we look carefully into the picture, and I can determine this by looking at my color bar here. Now I have the white, the black with single shade of gray. I have narrow shade. But look at this picture here. I have wider range of shades of gray. I can just say this by looking at my sidebar, okay? Even without looking at the picture. Now we will look at the picture. How about this sinus? Is it more black? I'm sorry, is it more bright? Being bright in the first place. Now is it more bright or less bright? It is, take a second and look carefully. It is what? It is less bright. And the parenchyma here, is it more dark or less dark? It was dark in the first place. Now, is it more dark or less dark? It is less dark. Okay. Now, both has become into the more shades of gray. They are less striking in difference. So in other words, which picture has got the more differentiation, has got better demarcation? Yeah, absolutely right. I agree with you. This picture. Why? Why is this? Because here the sinus is more white and the parenchyma is more black. That is to say, there is striking difference. Okay, they are differently different. They are obviously different. They are strikingly different. They have more contrast. And that is what dynamic range is also called in some machines, because it delineates the contrast between the structures as such. So now, because each one of them is more evident, and I can tell which is which, because there is difference in them. Now, there is striking difference, because normally and naturally the difference between white and black is striking, contrary to the difference between here two shades of gray. Yeah, admittedly this is a dark shade of gray and this is light shade of gray, but both are what, more or less towards the gray. Okay, so this picture has got more differentiation and demarcation. Okay, let's take another example. Why? Because here we have wider range. Okay, in this picture we have what? In this picture we have the endometrium. This is a picture of the uterus. And we have here the endometrium, we have here the myometrium, we have here also it is the same, but I've changed something, endometrium and the myometrium. Okay, now in which picture can you see the demarcation or the differentiation more? In this picture, yeah, absolutely right, because here the myometrium is almost black and the endometrium here is almost white. We have here a narrow dynamic range, thus we have more contrasts. Okay, now I hear the question lurking in your mind, why can it be the gain? Why can it be the gain? Why can that what I have changed here is that I have increased the gain here in this image? This is what you want to say, right? Because apparently this image appears to have more gain. Okay, I will assume this. I will humor you. Look at this strip of the image. Now, which image, in which image this strip is brighter? This image. So now you assume that this image is higher in gain, and in the same time you say that in this strip it is brighter in this image, which seems to you to have less gain. Voila, the confusion, because it is not the gain that I have changed. What I've changed here is the dynamic range. It is narrow here and it is higher here. Thus we have here more shades of gray and there is less contrast in here. So it is not the gain, because if it was the gain, why the myometrium here is darker? Okay, it is not. Why the endometrium is brighter? So it is not the gain. Here structures have varied differently. Okay, if it was the gain, then all of the picture would have been increased or decreased in the gain. But what happened here is the myometrium has got darker, so it is not the gain, whilst the endometrium has got brighter. Okay, how can it be that one structure changed and the other structure changed differently? Okay, the gain changes the brightness of the image unanimously in the same manner. But here what happens, the myometrium is darker, while the endometrium is brighter. And why is this? Because what I have changed is the dynamic range. I've increased their contrast. Now, in order to understand it, okay, I will explain it in another way diagrammatically. Let's say, how is this? Okay, let's say I have here the dynamic range of 5. This is the black, this is the white, and this is my shade of gray, like this 3. Okay, okay, what happens here? Here I have my myometrium near the black and the endometrium near the white. So when I decrease the dynamic range as such, what happens? Okay, I ask the machine to narrow the range. I ask the machine to decrease the shades of gray. So what happens? There is the black and here is the white. The shades I already have here, the gray. Now I ask the machine to decrease the shade of gray into one shade of gray. Okay, so what will happen? These shades of gray will start to merge. So the myometrium will move to the nearest dark shade, appearing here almost black. And the endometrium will, the shade of the endometrium will merge with the nearest light shade. So the endometrium will appear here. And this is what happened, creating more contrast. because what happened, that the shades of gray has merged, and thus the structures that tend to have darker shades are all has got into the dark, okay, and the structures that tend to have lighter shades all are whiter. So what happens, I increased their contrast. Because now they are what, they're almost black and white, so I increased their contrast. So this is what happens when we decrease the dynamic range, we have more contrast. So this can be used when I want to differentiate between two structures that already have difference in their shades, as in the myometrium and the endometrium. Let's see another situation. If here in the same example, I have here my myometrium and here my endometrium. What if I have here a polyp, and the polyp would appear similar in its echogenicity to the endometrium, similar in its brightness to the endometrium? When the dynamic range was 5 as such, the endometrium was in this shade, light gray, and the polyp was in this shade, okay? So if I decrease the range here, as I did before, what will happen? As we just said, that the shades will start to merge. So the myometrium will appear here and the endometrium will merge. So I would see the endometrium here and the polyp. So what happens? I lose the polyp. I do not see it because it is merged and fused with the endometrium. So in this situation, was it good to decrease the range? No. So in conclusion, when I have two structures that I wanted to delineate the difference between them, and they already have difference in their shades, like the myometrium and the endometrium, they already have difference in their shade. One is dark gray and the other is light gray, then I would decrease the range in order to demarcate them and to delineate the difference between them. But when I have two structures that are in the same spectrum, they are both light, but one is lighter than the other, then they are both light, but one is lighter than the other, they have similar shades, then I do not decrease the range. On the contrary, I increase my range in order to delineate the subtle difference. I increase the shades of gray so that I can see the subtle difference between them. So this is how we can use it. Let's see how this can be applied in our example. Now here I have the same example as the endometrium. I have here the polyp and here the polyp. Where can you see it more clearly? In this image, when the dynamic range was more, because now I can see that this has certain shade that's lighter and the endometrium has got a little darker, but here they are fused together because here I have less dynamic range. Okay, so this is how can we use the dynamic range. Okay, I'll give you yet another example that's very useful. Okay, here now, back in our early days of residency, when we start to work, they used to tell us what, when we encounter a case of renal stone, and that's very common, we meet it every day in the practice. We encounter every day in the practice. Now, when we see a case of stone, what will happen? They used to tell us to decrease the gain. But what happens when we decrease the gain? The parenchyma will decrease, the sinus will decrease, and the stone itself also will decrease. Isn't it right? Now, my advice to you now, after you understood the dynamic range and how to adjust it, is that you decrease the dynamic range. Now, the parenchyma will decrease, it will be more black, but the stone would be more white. So I would see it more clearly, it will shine, because it is already lighter, it has more brightness. Okay, so what will happen? I will exaggerate the difference between the stone and its background so I can see it easier. So just try this and tell me what will happen, and I'm quite sure that you'll thank me later for this advice. Okay, so I want you to revel in this point of enlightenment where we understood this function clearly and we can apply it, and we have known when to do so, in what manner. Now let's do a very quick recap. Now we are in the B mode. We have discussed the depth, and in the depth there was the depth itself, then the zoom and the wide view. Okay, and then the B. Now the mnemonic is always what? RBD. Bravo. Now the B, the brightness, overall gain, that is, and the TGC, sector by sector, and now the dynamic range, the controlling the shades of gray. It remains for us in the B mode what? The R, the resolution. Let's see what we have here in our resolution. Okay, the resolution. And the resolution, we will discuss 3 points: the focal zone, the frequency, and other stuff. Now here we have the focal zone here. Okay. Now, by changing the position of focal zone, we change where we want to see best. If we move the focal zone here to be in the upper part, this part will be in the best resolution. Okay, so par contre, on the other side, on the other hand, here the lower part would be in poorer resolution because I move the focal zone upwards. If I did the reverse and I move the focal zone downwards, then I would have here improved resolution. In order to appreciate it, look at the vessels here. I can hardly see this one, but in this picture, where I moved my focal zone, I can appreciate another one. So moving the focal zone allows you to determine where is the part of the picture that you want to see best. So move your focal zone to the area where you want the best resolution. Okay. Another example here. We have here a picture of the carotid. Okay. Now, where is my focal zone? Here, my focal zone is in here. So if I want to measure, let's say, the intimal medial thickness here, I would move my focal zone towards it. So here I have sharper details, I have better resolution, so I can measure it more accurately. Okay, so this is how we can use the focal zone and move it towards our area of interest here. Now, another function still in the resolution. Okay, I have here what? The frequency. Now, it is well known to all of us that when we increase the frequency, I would have better resolution, yet poor penetration. Here my frequency is 6. Look at the picture of the vessel. It's not very clear, but the waves have penetrated till here. Here I have increased my frequency and I can see my vessel better, but here I almost lost my image. It's okay, so long as this is the area I want to see. All right, so by increasing the frequency, I would have better resolution in the superficial part, because we know that increasing the frequency, okay, makes better resolution, but poorer penetration. That's why the superficial linear probe, of course, have higher frequency than the deep curvilinear probe. Here the same. We have here the frequency of 9 megahertz, and this is how we can see the lumen or the vessel. By increasing our frequency, we have here better resolution. Okay, so we have here discussed the frequency and the focus. All right, now to the much awaited slide. Let's see together where everything is okay. As we said before, we have agreed together that there might be differences in the interface, but more or less it be like this. Now I have here the frequency with the rotatory knob as such. Now I have here the focus, where I can move the focal position, as we just said, in order to see part of the image in better resolution. And by the way, you can have more than one focus, okay, but it's not advisable to have more than one or two, okay. Here you can change the number of focus into the number you want, but it's not advisable to make it more than one or two. Here we have the dynamic range, okay, you can determine the range you want. Okay, here is the tissue harmonic imaging. Press it on, click it on, because it will give you a better picture. Here we have the field of vision, should you want it to be narrow or wide. Okay, now let's see this tissue harmonic function. Okay, as we can see here, when we turn it on, we have here better image than this. It is of special importance in the shadow, as we can appreciate the difference between these two pictures. Here the shadow is much better. So yeah, activate the tissue harmonics. This is the function of speckle reduction. We activate it. We have here less speckles than here, so press it on. The same thing with the compound imaging. It chooses the best image, and that was it. So wrapping things now. Now we have finished. Congratulations, the B mode. Now the B mode. What was the mnemonic? What we have in our blood? The RBCs, and substitute the C for D, and that is the mnemonic RBD. The R, that's the resolution. You can choose the frequency and improve it. Okay, but take care. This is make poorer penetration. You can move the focus point to the area you want the better resolution or the best resolution. Other stuff like the tissue harmonics, please press it on. Now we have the R. What about the B, the brightness? We have the overall gain, where you can increase or decrease the gain of the whole picture. Now we have the TGC, where you can increase or decrease sector by sector. Now we have the dynamic range, the shades of gray, and then we can use it to increase the contrast or decrease the contrast. And lastly, the depth. The depth itself, we have to change the corresponding depth according to the object of our interest to make it in the center of the image, filling it. The zoom, we can zoom on the structure we want. And the wide view, this is interesting function where we can increase the coverage of the waves, make it almost as virtual complex or a trapezoid view. And that was the B mode. Okay, I hope this is clear. Don't forget to immediately apply all of what we have discussed, and thank you.